All right, we are going to start with 6.2 reflection. So make sure that you are on notes 6.2. Okay, you're going to have to bypass 6.1. We're going to come back to that later on in the unit. So make sure you're on 6.2, reflections. So what exactly is a reflection? Okay, a reflection is probably what you're thinking. Okay, so reflection is what you see in the mirror every morning. Okay, it's a mirror image. And what happens when you look in the mirror? Okay, things are reversed. Okay, so let's play around with that idea with some points on our graph. So it says graph point A, and it's 3, 5. So 3, 5, and when I plot the point, I'm always going to label it with the letter that it's given. And then it says graph the image of A after a reflection in the y-axis. So the y-axis, right, is going to act like the mirror. So if you are point A and you're looking into the y-axis as your mirror, where is your image going to appear? Well, if you are 3 units away from the mirror, okay, you're going to go 3 units to the other side of the mirror, and that's where your image is going to appear, directly in front of you. So the image of A is called A prime. That little sort of almost looks like an apostrophe. We say prime. So that indicates that A and A prime, they're somehow related, but they're not the same exact point. So it says state the coordinates of this image. So A prime, the coordinates are -3, 5. So when we plotted A and we reflected it in the y-axis, we got A prime. So what happened? What was A when it started? A was the point 3, 5. And when we reflected it on the y-axis, it became -3, 5. So we're going to start to look for patterns as to what happens. Okay, so what's similar and what's different right now? So we see that the y's stayed the same, but hopefully you're seeing that the x's changed. So now let's do number 3. It says graph point B, which is 6, 2. So 6, 2, label it with the letter that it's called, B. And now it says graph the image of B after a reflection in the x-axis. So now the x-axis is our mirror, and we're at point B. So point B is 2 points away from, or 2 spaces away from the x-axis. So now where would your reflection be? Your reflection would appear 2 points, or 2 spaces below the x-axis, and that image we're going to call B prime. Okay? So they're somehow related, but they're not the same exact point, so we're going to call it a different letter. And it says state the coordinates of that image. So B prime, the coordinates of B prime are 6 to the right and down 2, so 6, -2. So what happened there? Let's sort of summarize like we did in number 2. So from point B, we reflected it in the x-axis and it went to B prime. It started out at point 6, 2. And then what did it become when we reflected it in the x-axis? It became 6, -2. So let's look and see what happened. So when you look at this, hopefully you're noticing that the x's stayed the same, but the y's changed. Okay, so what do you notice? What did we notice in 1 and 2? Okay, so when we reflect in the y-axis, what did we notice? Okay, the y's stayed the same. The x's were opposite. All right, and then what just happened in 3 and 4? Let's see, I think I'm going to see if I can move this sentence up. Oh, I can. Beautiful. What happened in 3 and 4? So when we reflect in the x-axis, what stayed the same? Okay, the x stayed the same. The y's were opposite. Okay, so now let's sort of summarize here. So before the reflection, our point was just plain old x, y. And then when we did any type of reflection, okay, so when we reflected, what happens? After a reflection in the x-axis, how does our point change? When we reflect in the x-axis, okay, our x's stayed the same, but the y's changed. So then when we reflected in the y-axis, the x's changed, but the y's stayed the same. Okay. Now this next one, I'm going to give you the rule for it, and then we're going to practice it. You're going to see what happens. So now, what is this all going to mean? After reflection in the line y equals x, okay, reflection in the line y equals x. Well, we got to see what that line looks like, but I'm going to tell you what happens. So when we reflected in the line y equals x, we flip-flop our points, or we flip-flop our coordinates. If it goes from x, y, when we're reflected in this line y equals x, we switch the order, okay? So let's make a note there. We're going to switch the order of x and y. So let's go ahead and flip the page, and let's do a little practice with that. Okay. So this one says, give a triangle ABC with our coordinates. Let's plot those points and let's label them. So point A is 3, 1. Label it A. Point B is 5, 3. Make sure you label it B. And point C is 6, 1. Okay, let's grab a straight edge. Okay, and connect those three because we're talking about a triangle. And what do they want us to do with this triangle? They want us to reflect this triangle over the line y equals x. So let's have a discussion here about the line y equals x. If I told you to graph that, we know that there's a 1 there. Okay, so my slope is 1 over 1. Do I have a y-intercept here? There's nothing there. So if there's nothing, what is my y-intercept, or what is my beginning point? My beginning point is 0. So let's graph that line. So I begin at 0, and then I go up 1, right 1 to graph this line, or reverse it, go down 1 and left 1. This right here, grab your straight edge, is the line y equals x. This is going to become our mirror. This is what we're going to reflect that green triangle in. So I'm going to, again, put arrows on it. Let's label it y equals x. So this line is now my mirror. So where do you think that triangle is going to appear when I reflect it in that mirror? Okay, hopefully you're saying, okay, well, if it's below that line, when I reflect it, it should appear somewhere up there. So that's sort of our prediction. Okay, let's see what truly does happen. So what did I tell you was the rule? Okay, let's look back. What did I say was the rule? Our initial point, x, y, all of a sudden flips, switches the order. Okay, so let's write that over here so we have it in front of us. When we reflect in the line y equals x, our point flip-flops. Okay, so let's start. A was 3, 1. So what's its image going to be when I reflect it? Flip-flop, okay? Switch the order. So it's going to become 1, 3. So B is 5, 3. when I reflect it in the line y equals x, what is its image? What's b prime going to become? Flip-flop that 5 and 3 and make it 3, 5. So then let's do that last one. C is 6, 1. And what is its image going to become? Again, flip them, switch them. 1, 6. Now let's go and plot those new points. So A prime is 1, 3. Label it appropriately. Call it A prime. B prime is 3, 5. And C prime is 1, 6. Now let's connect those dots. Okay, and that last one wasn't the straightest of lines. Let's do that again. Oh, I'm kind of off here today. So my prediction was correct, and let's label that C prime. Okay. Now let's think what happened. Okay. So what I want you to do is I want you to come up with some properties of reflections. Okay, well, what does that mean? Okay, things you know about reflection. So when you reflect a picture, what happens? Okay, so when you reflect, we'll say a picture, what happens? Okay. So if you need to take, okay, and look that up, that's what I want you to do, hint, hint, wink, wink, okay, Google it. Properties of reflections, type that in. What happens when you reflect a picture? Okay, Google it. Like I said, look it up. Go on a math website, find properties of reflections. I want you to look it up. This is your sort of little homework, okay, beyond the video. I want you to take some time, and I want you to see what 3 properties you can find when you look it up. So when you shut this off, that's what you're going to do. All right? See you in class.